Okay, so in the first part of this example, we came up with the following factorization over the real numbers. We had the repeated 0, x equals 1, and this irreducible quadratic 2x squared minus 3x plus 6. So to try to find the rest of the zeros, maybe complex numbers, we're going to look at using the quadratic formula on this part, 2x squared minus 3x plus 6. And so we'll use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. This with b equals negative 3. A equals 2. C equals 6. And so that becomes 3 plus or minus the square root of negative 39 over 4. And since there's no real number square root of negative 39, that's why we know we had no other real zeros, but there are two complex zeros here that we find by separating the 39 and the minus 1. And over the complex numbers, we just take the square root of negative 1 to be I. So we have these two zeros, 3 minus the square root of 39 times I over 4, and 3 plus the square root of 39 times I over 4. So those are two more zeros in addition to the real zero, x equals 1, that we had already found with multiplicity 2. So there are 4 zeros counting multiplicity, x equals 1 with multiplicity 2, and these two complex zeros each with multiplicity 1. So the complete factorization of the polynomial over the complex numbers looks like what we started with, x minus 1 squared, times a factor for each of these two complex zeros of the form x minus c. X minus 3 minus the square root of 39 I over 4, and x minus 3 plus the square root of 39i over 4. And so that's the factorization of that polynomial over the complex numbers. This here is the factorization over the reals.